Okay, so I've scanned the pages of the textbook. These pages here, I think, will have your combined science textbook. This is actually your first page. So I'm going to start now. Okay, just if you can't hear me at any point in time, please unmute yourself and let me know. Okay, because I wouldn't know whether you hear me or not along the way lah. So just let me know. Okay, so let's start now. Now, in chapter 1, okay, this is actually the chapter of measurement. So we are actually going to look at measurement itself. But of course, 1.1 is a general introduction of physics. So as you look at it, okay, physics is the study of our natural world. Okay, generally is broken down into 4 main fields. So general physics is actually your chapter 1 to chapter 6. Then for thermal physics, it's actually chapter 7 to chapter 9. Light waves is actually chapter 10. Then electricity and magnetism is actually from chapter 14 to chapter 18. Okay, so do take note of this, that we are going to cover all the chapters along the way based on the schedule that I've given you. Okay, so this is just a quick intro in terms of how things are broken down in terms of general physics, thermal physics, light waves and sound, electricity and magnetism. Okay, so let's go on to 1.2. Now, I want you to your textbook, there's always this part here, okay, about the learning outcomes. Referring back to this to let you know that for this segment, what are we gonna be extracting out? So first part here, okay, if you look at the first point, it's really about understanding what are physical quantities. So the definition is here. So in your summary sheets, please have this down. When I write the word D, it means definition. So you should have this under your definition for physical, for the chapter of measurements. So physical quantity is a quantity, so do take note, people tend to miss out this word, that can be measured. Okay, it consists of a numerical magnitude, it means that it consists of a number, and it must have a unit. Okay, so physical quantity is a quantity that can be measured. So things that can't be measured is not a physical quantity. So do take note of that. So I've covered the first one, which is really purely a definition. A lot of things that you are learning in terms of length, area, speed, all these are physical quantities. Okay, now next one that we're going to go into is actually to list the base quantities and their SI units. Now, how many base quantities do we see here? We have 1, 2, 3, 4, 5, 6, 7. So there are 7 base quantities that you need to that's indicated in the textbook. However, what you have is, if you look at this specifically, they are only looking at length, mass, electric current, and temperature. So there's only 5 key ones that you need to know. And hence, length you need to know, mass, time, electric current, thermodynamic, temperature. Okay, these are the 5 that you need to know. The last 2, okay, is just for your information that they are base quantities. But the one that you'll actually be using most often is actually this 5 indicated here. Okay, what are the SI units? Meter, kilogram, seconds, ampere, and Kelvin. Okay, most people tend to get a temperature, SI unit for temperature wrong because we're also familiar with the concept of degrees Celsius. However, the SI unit for temperature is actually Kelvin. Okay, and the symbol is a capital K. So do take note, this is a capital K, not a small k. Electric current, most of the Sec 4s you have covered this already. So the units for electric current is actually ampere. It's actually a capital A here. Time will be in seconds. Now, mass is the one that most people tend to get a bit more confused kind of thing, because like I thought, kilo is a prefix, then why is the SI unit kilogram? Okay, so there's a historical idea behind why it's a kilogram. We're not going to go into it. You can go and YouTube search about it. But do take note, mass, the SI unit is kilogram. Okay, the symbol is kg. And last one for length, the SI unit is meter. Okay, the symbol for it is m. So these are the 5 base quantities that you need to know. You need to know the SI units and the symbol for the SI unit. Okay, so we are done with the second part. And the last one we're going to look at is the use of prefix and symbols to indicate very or very small SI. Okay, so let's go into it. Now, So this table, you will need to remember them. Okay, typically it's tested quite often in terms of the unit conversion. So for unit conversions, it's quite important. You need to know how to do it. So on this part here, I do take note. I'm going to write down here. So under your summary notes, okay, I need you to write this down under the important concepts. So IC stands for important concepts. So under chapter 1, important concepts, the first one is about prefixes. So with regard to prefix, first thing, you need to learn how to remove the prefix. Okay? Now, to remove prefix, you actually will multiply it by the factor. So for example, what I have is typical one, let's say 3 kilometers. I want to convert it to meters. So I need to remove kilo. So to remove kilo, what I'm going to do is multiply it by the factor, which is 10 to the power 3. So multiply by 10 to the power 3. If you press your calculator, what you're going to get is 3000 meters. Okay, so to remove prefix, you actually multiply by the factor. The next important concept you need to know, to insert prefix. Okay, to insert prefix, what you're going to do is that you need to divide by the factor. So let's look at it. For example, let's use the same example again, but maybe now this time we use 5 meters. 5 meters. Let's convert it to kilometers. So can you see here that from no prefix, just meter alone, now we're going to add kilometer. So kilo is the prefix that we're inserting. So in this case here, we will actually divide by 10 to the power 3. Because to insert, you will divide. And by the factor for kilo is actually 10 to the power 3. Right? Let me write clearer a little bit. 10 to the power 3. So in this case here, what you're going to get, if you press your calculator, you should have 0.005 kilometers. So to remove the prefix is to multiply. To insert is to divide. So sometimes the questions may ask you, what if I want to convert? Okay, so we have important concept of removing prefix. We have inserting prefix. And the last one, let's say you want to change the prefix. So I'm going to write down here, changing prefix. So how do we change the prefix? Okay, quite simple. Actually, you will first remove the prefix. So actually, it's a two-step process. To change prefix, you will first remove the original one, then you insert the new one. Okay, so it's actually a build-up of what we have picked up there. So one example would be, let's use a simpler one. For example, let's use kilometer again. 2 kilometers, I want to convert it to centimeters. Okay, 2 kilometers convert to centimeters. So how to go about doing this? First thing, let's remove the prefix. So to remove kilo, I need to multiply by 10 to the power 3. So if I were to do that, I'll get 2000 meters because I remove kilo. Now, to insert centi, okay, I'm inserting centi here. So I'm going to divide by 10 to the power minus 2. So you press your calculator carefully, what you're going to get is 200,000 centimeters. So in terms of converting prefixes, in terms of removing, in terms of inserting, these are some of the important concepts in this chapter that you need to know. And of course, this table is really important. You need to remember it. So for some of you, in terms of your summary sheets, you might want to include this whole side summary sheet. Okay, now just a little things to take note of. Most people tend to confuse mega and milli, okay, because of the capital M and small m. So do take note, mega is a capital M, milli is a small m, okay. And the last one, micro, because most of you see micro, mega, milli, or m. Do take note, this is a Greek symbol called mu, okay, so do know how to write this properly. So this is a symbol for micro. Okay, so these are some of the common prefixes that you need to know from 10 to the power minus 9 to 10 to the power 9. So do include this in your summary sheet. Okay, so what we have actually completed the first 3 learning objectives. okay, found on section 1.2. Okay, so this is for this part over here. Now we're going to go on to the next part. You've learned your math, so I'm not going to go through it. Okay, now under 1.3, what is the concept or the idea of measurement of length. So what's important in these few pages? Okay, I think most of you know that the SI unit for length is meters, so I'm not going to go through it. But typically, if you look at all these pages, right, they introduce to you this idea of the meter rule and measuring tape or tape measure. Okay, they also introduce to you the idea of precision of an instrument, and they introduce to you vernier caliper and micrometer screw gauge. So let's do step by step. Okay, now in terms of measurement of length, let's look at this whole page here. Okay, do take note. First thing, meter rule can measure length up to 1 meter, because a meter rule is actually a 1 meter ruler. So that's why the maximum length of a meter rule can measure is only up to 1 meter. Okay, now, however, for tape measure or measuring tape, okay, it tends to be able to go longer than a meter. So do take note in terms of the length that you want to measure. A meter rule is up to 1 meter maximum, whereas if you use a measuring tape, it can go longer. I mean, quite common sense, right? Now, this is for this part here, but you realize, how come there's this idea of, in our learning objective, show an understanding of how sizes of objects such as an atom and earth can range in order of magnitudes? So did we ever get tested on this before? Is this really important? Where is this actually at? So this first one here is actually on the diagram at the bottom over here. Okay, so you can see all this over here. The ones that commonly get tested is actually this one over here. The typical size of an atom, you need to know that it's actually 10 to the power minus 10 meters. Okay, I've seen it in the TYS quite a few times already, so you need to take note of this. Okay, these are the ones that is a bit weird, you might not be so sure about. Next one, width of a human hair is actually 10 to the power minus 4 meters. Okay. Now, if you were to go on to the next page, you realize, this one like got test before, radius of the earth. Yes, radius of the earth is actually in the range of 10 to the power 6 meters. That's the radius. But if I test you on the diameter, okay, the diameter is actually 10 to the power 7 meters. That's the diameter of the earth. So you need to know the range, what's the radius of the earth in terms of what's the radius of the earth and also its diameter. These are the few that commonly like to get tested, and most people wouldn't know what the answer is because you need to remember the range and have a feel of it. Okay, so actually this part here we have settled in terms of the first objective. You can see here we focus on the atom and earth, but I also added in terms of the human hair. Okay, what of the human hair is actually the average width. Okay, so the width of a human hair. So do take note of this tree, like it's just kind of like either you know or you don't know kind of question. Most of the time it comes out in MCQ. Okay. Next one, we're going to describe how to measure a variety of length using the proper instruments. We have covered meter rule, we have covered tape measure. We're going to go into vernier caliper and micrometer screw gauge. I think in Sec 1 we have covered this quite a fair bit. So I'm just going to use the textbook to just go through it. If you got any if you like to have some practice, you can look through back in your worksheets in Sec 1. If you don't have them, please approach your teachers and ask them for some extra material. Okay. Now, let's go to your vernier caliper. Okay. In terms of the practical uses, so you can see here for the vernier caliper, we have the inside jaw. Okay, we have the tail used to measure the depth of an object. We have the outside jaw used to measure the external diameter. This three is good to know because you may use the vernier caliper, but in actual fact, most of the time, the vernier caliper questions that comes out in the theory paper is about reading the measurement. Okay, so you need to know how to read the vernier caliper. Okay, so you will get something like this, and you need to know how to read it. Okay, so that's the part where some people have some challenge. They might not know how to go about reading it, even after 4 years. So not very good. So let's go through it a little bit. Okay, first things first. Okay, you can see that there are many steps here to tell you the whole thing. Okay, so you can actually look through all these steps to learn how to read the vernier caliper. But I'm just going to jump straight into looking at the example. Okay, now first things first, let's look at this one. Right, example of the observed reading. So you can see here they say the reading is 3.14. How do they get the 3.14? Now do take note, the first number here actually comes from, sorry, not the first number, the first two numbers. Okay, so 3.1 actually comes from the main scale. This 4 over here actually is a reading that you get from the vernier scale. Now, how to get the 3.1? So what you need to do is look at the main scale. Okay, where does the 0 of the vernier scale align? So you can see it is over here. This is the 0 of the vernier scale. You can see that it has crossed 3.1, but it has not crossed 3.2 yet. So we know that the main scale reading is 3.1 something. Okay, not because it has crossed 3.1. So that's why we got 3.1 over here. Now, in terms of the vernier scale, the number 4 over here, how did we actually get 4? So you need to now read the vernier scale. So this is 0, this is 1, this is 2, this is 3, now for 4. How do I know the 4 is the correct reading? Because to read the vernier scale, you need to find the alignment, okay, of the vernier scale with the main scale. So look for the line that aligns the vernier and the main scale. So this whole part here is aligned. So we know that the vernier scale reading is a 4. So what we're going to get is 3.1, 4. Okay, 3.1 from the main scale, 4 from the vernier scale. Okay, so this is how they get the 3.14 in that sense. So in terms of a general reading, it's always main scale plus the vernier scale. So this is how you go about reading the vernier caliper. Okay, in terms of zero error, I like to say that actually for combined science, they don't really test so much about the zero error. So far, historically, not wrong, it hasn't really come up before. But just in case you never know, because it's in a textbook, you need to definitely know it since it's there. So we're going to go through the positive zero error and the negative zero error. So let's look at the positive zero error. Now, when does positive zero error occurs? So for example, when I'm not measuring anything, I close my vernier caliper, then you realize, how come the 0 here don't align? Okay, when the 0 is not aligned, you actually have a zero error. So when the vernier scale is on the right hand side of the main 0, so I say again, when the 0 on the vernier scale is on the right hand side of the 0 on the main scale, when you see something like this, okay, this is when we know it's a positive zero error. Okay, positive error. Now, so once I know it's a positive zero error, what I need to do is generally just read the main scale and the vernier scale. So this is 0, this is 0.1. So I know that my main scale reading for here is a 0.0 cm. In terms of the vernier scale, this is 0, this is 1, this is 2, this is 3. So you can see the 3 of the vernier scale matches the line on the main scale. So we know that the vernier scale is a 0.03 cm. And as such, when you add them both up together, you're going to get 0.03 cm. Now, then you're saying, how come I'm positive here? So if it is a positive zero error, you must have the positive sign there. Okay? So do take note of this. Then the question is now, if I got positive zero error, what do I do with the reading? So down here, if you read carefully, the main scale for this is 3.1 still, 3.1 cm. But the vernier scale, you can see here 0, 1, 2, 3, 4, 5, 6, 7. The vernier scale now becomes a 0.07 cm. So if you add them up, you get 3.17 cm, which is reflected here. So this is the reading with a positive zero error. I know the positive zero error is 0.03. So what I'm going to do to correct the reading, I will always take my measurement minus my zero error. As such, your final reading will be 3.14. Okay, so that is for the positive zero error. Now we're going to go into the negative zero error. So let me zoom in a little bit for everybody. Okay, let me scroll down. Now we're going to go into the negative zero error. How do you know it's a negative zero error? So if you compare the top and the bottom, what you realize that this time round, okay, my vernier zero is on the left-hand side of the main zero. Okay, so I say again, the vernier zero is on the left-hand side of the main zero. As such, this is now a negative zero error. Okay, how to read negative zero error? Do take note this is slightly different from the positive zero error. What you need to do is to count backwards. So typically for a negative zero error, it will always be negative 0.0 something cm. So what is this value here? It's actually seeing where you read. So you count backwards. This time around, because of a negative zero error, you count backwards from 10. So what you're going to have here is 1, 2, 3. So you realize when I count backwards, it's 3. So I know it's a negative 0.03 cm. Okay, I repeat this again. For negative zero error, what you need to do is to take note, the zero error always be negative 0.0 something cm. To find out what is this something, the last digit over here, what you're going to do is to count backwards from the number 10 on the vernier scale. So the line is aligned over here. What is the value that I want to know? It's actually counting back from 10. 1, 2, 3. So because when I count back to this line over here that matches the vernier and the main scale, I'm going to get a negative 0.03 cm. Okay, so this is for the negative zero error. So main scale, let's read the whole thing again. Then the measurement itself, as I look at here, how did it get 3.11? So first things first, main scale, you can see here, it has crossed 3.1 but haven't crossed 3.2. So my main scale reading is a 3.1 cm. Okay, sorry, 3.1 cm. My vernier scale reading, so which is the line that's aligned, is over here. So count 1. So this is 0.01 cm on my vernier scale, and hence I got 3.11 cm. So same thing to find the corrected measurement. Okay, I take the measurement that I've done here. Once again, you realize I subtract it by the zero error. Okay, so I don't care whether it's a negative or positive zero error. I'll always subtract the zero error. Okay, so you can see here, if it's a positive zero error, I subtract the positive number. If it's a negative zero error, I subtract the negative number. Okay, and hence my value will still get back the same value, which is 3.14. So this is about how you go about reading your vernier scale. Now, if you are not sure about whatever I'm talking, okay, you can go back and relook at this again after the thing has ended, because I'm uploading this on YouTube. Okay, so you can use this to try to recap a little bit more and then do some examples from your segment worksheets. Okay, so this is for the vernier caliper. Okay, and I included the positive and negative zero error. Now, we're going to go on to the next instrument that we're going to use, which is called the micrometer screw gauge. Okay, the micrometer screw gauge is actually quite an important instrument. Okay, that because it can measure very, very small readings. Okay, so the steps are here in terms of how to go about reading it. Once again, I'm just going to jump straight into all this over here. So first things first, of course, when there's no zero error, what you're going to realize that this is called the datum line. The datum line will match the zero over here. Okay, so just want to say this is called the main scale. Wait, sorry. Okay, this portion over here is the main scale. This portion over here is called the thimble scale. Okay, Then this middle line over here, as mentioned, is called the datum line. When there's no zero error, what you realize is that when I close the instrument, the datum line will actually match the 0 on the timbal scale. Okay, this is when there's no zero error at all. Okay, so this is the normal situation. So in the normal situation, okay, let's see how we go about reading it. So let's zoom in a little bit more. Okay, so let's look at this example given here. Now, to find how to read the micrometer, it's actually the same concept. I'm going to take the main scale and then I'm going to add the timbal scale to give me my final reading. So first thing, let's read the main scale. Now you can see this is 0, this is 5. So if I were to use a bit of my common sense, this is 0, so this will be 1, 2, 3. Okay, a bit thinner. Let me make my pen thinner a bit so it's easier for everyone to see. So this will be 1, 2, 3, and 4. Now, you see there's a line at the bottom here. So if this is 0, this is 1. Can you see this line is in between 0 and 1? So this will be 0.5. This line over here will be between 1 and 2. So this line is actually 1.5. This one is actually 2.5, so on and so forth. So the line at the bottom is actually the 0.5s, okay, between the readings over here. So if I were to go in the same concept, so this 5, 6, 7, 8, this is actually 8.5. So the main scale reading will always read the last thing you can see on the main scale. So you can see here, the last thing I can see on the main scale is actually 8.5. So the main scale reading here is 8.5 mm. For the timbal scale, I'll need to look at the datum line, which is this line over here, and match it to the line here on the timbal scale. So you can see here the datum line matches number 40. So the timbal scale is actually 0.40 mm. So when I add them up, I got 8.90 mm. Okay, so you can see this is the main scale reading. Just read the last number here. For the timbal scale, you look at where the datum line is matching the numbers. Okay, so this is for the normal reading. But let's say we have a positive zero error. How do you know that there's a positive zero error? So you realize the datum line is not aligned to 0. How come now the datum line is above? So what happens is that when you realize the 0 marking on the timbal scale, okay, so as mentioned here, the 0 marking on the timbal scale is below the datum line. So 0 marking on the timbal scale below the datum line. So this is a positive zero error. Then how do you go about reading it? So the main scale here, what you realize, main scale I can't see anything. I think the only thing I see is 0. So our main scale is 0.0 mm. In terms of the timbal scale, the datum line matches number 3 on the timbal scale. So the timbal scale will be 0.03 mm. As such, the positive zero, as such, the what you're reading here will be 0.03 mm. And because it's a positive zero error, you put a plus in front. Okay, so that's how you go about reading a positive zero error. And let's practice the reading here. Main scale, the last thing you can see here is 8.5. So now 8.5 mm. This line over here, this is 40, 41, 42, 43. So my timbal scale is 0.43 mm. So if I were to add this up, this is 8.93 mm, which is indicated here. Now, so what is my corrected reading? Because I have positive zero error, I want to make corrections to it. So what do? This is actually the measurement you have taken. This is your positive zero error. So this is the zero error. So to find the corrected reading, once again, is very similar to the vernier caliper. You take the measurement minus the zero error, and that's what you're going to get. So this is for the positive zero error. Now let's go on to the negative zero error. So how do you know there's negative zero error? You realize now this time round, the 0 marking on the timbal scale is above the datum line. Okay, it's above the datum line. So the question now is, okay, So it's above now, I know it's negative zero error. How do I go about reading it? So similar to the vernier caliper, you need to count backwards. So for a micrometer, generally the zero error, okay, you must count backwards. So it's 0 point something, okay, 0 point something mm. Now if you look at here, if I count backwards, it's a 1, 2, 3. So I count backwards 3, that's why it's a 0 0.03 mm. Zero error. So of course you can jump more. So the key idea here is just need to jump back. Okay, count it reverse order. Instead of the generally you always count upwards. For the negative zero error, you actually count downwards. Okay, so do take note of that. So this is a negative zero error because the zero marking on the thimble scale is above the datum line. Okay, so we realize this is because you have count backwards, it's 0.03, so it's a negative 0.03 mm negative zero error. In terms of the reading here, so let's practice again. The main scale, the thimble scale. Main scale, what I read here, you realize 5, 6, 7, 8. Last thing I can read is 8.5. So my main scale reading, 8.5 mm. What I have over here, 35, 36, 37. So the thimble scale is 0.37 mm. So this is 8.87 mm. Whatever that I have here. So how do I, this is the measurement I've taken, but there's a negative zero error. How can I make correction to it? So once again, you take the measurement and then you subtract it by the zero error. And when after I subtracted, I'll get 8.90 mm. So this is how you go about reading your micrometer screw gauge as a quick recap of what you have done in Sec 1. Okay, so reading vernier caliper, reading micrometer, typically likes to come out in your combined size paper under paper 1, which is the MCQ, and it will normally be the first question. Okay, now let's go back a little bit. Okay, going back a little bit. Now, under main concepts, okay, under important concepts, I need you to take note of this idea called the precision of an instrument. Okay. Now, what is precision? So you might want to write down this definition here. The smallest unit that an instrument can measure, it is known as a precision. So just now when we did the vernier caliper, we did the micrometer screw gauge, you realize, for those two instruments, what exactly is the precision? So for vernier caliper, okay, you realize just now we were able to do readings, right? Up to 0.01 cm. So that is the precision of the vernier caliper. Whereas for micrometer, you realize we could measure up to 0.01 mm. So the precision here, if you look at it, both also 0.01, what's the difference? The unit makes a difference. If you were to convert both of them to the same unit, so I'm going to convert mm into cm, this is actually 0.001 cm. So 0.01 cm for the vernier caliper, 0.001 cm for micrometer. You can see that micrometer is actually a more precise instrument. Okay, so precision, do take note, is an important concept you need to know. Okay, so based on this, we were to go down. Actually, there's a summary table. Okay, there's a summary table. Let me show you. Okay, it actually tells you for each of these instruments, what's the range that it can measure, what is its precision, and what is the example of its usage. Generally, for the examples, to me, I feel it's quite common sense, but if you want to try to remember it, then go ahead. But I need you to take note of this. What is important for your practical? Okay, measurement comes out quite a fair bit in practical. So for tape measure meter rule, do take note the precision is up to 0.01 cm. Vernier caliper, typically we will use cm also, 0.1 cm. For micrometer, the precision is actually, normally we will refer to it as 0.01 mm. Okay. In terms of the measuring range, do take note, micrometer, generally we'll use it if it's less than 2.5 cm. Okay, less than 2.5 cm. So we don't use micrometer for very big measurements. Generally, it's for very, very small instruments, very, very small measurements that we're going to take. So if we were to go back, okay, let's go back. Remember I told you there's always the learning objectives at the start of every section. So now, okay, if you think about it, we are able to, measuring tape, meter rule, you know how to use, but now we have also covered the vernier caliper and the micrometer screw gauge. So we're done with this objective, okay, learning outcomes. So this is for 1.3. Now, if you remember what we have done in your lower sec, there was one portion about avoiding errors. Okay, so parallax error typically is covered here. However, I like to say that whenever, okay, I use the word whenever you need to identify errors and stuff, typically we will not say the word parallax error. Okay, because parallax error is like a human error. It's like you never see properly lah. It's your problem. Okay, so so if ever question asks you to identify errors that you may make or that may have been made, typically we'll highlight the zero error. That's one of them. Okay, so if it is a zero error, what can you do to correct it? So you will take the measurement. Okay, and subtract it, and subtract the zero error from it. Subtract zero error from it. Okay, like what we have done just now. Okay, so zero error is one of the more it's an error that we've gone through just now. The other one is actually quite interesting. Okay, because to make measurements more accurate, what we can also do is to actually take multiple readings. Okay, and calculate the average. Now, taking multiple readings and calculate the average, what actually you are doing, you're actually reducing the errors made in the measurement. Okay, so do take note of this. So these are the two common ways you can always list in terms of trying to talk about how you can reduce the error. Now, of course, if the instrument doesn't have a zero error, then you're down to this only. Okay, taking multiple reading, calculate average to reduce the error made in the measurement. Okay, so this is regards to errors. You can see this is not really covered in this part. If you look at the learning objective, it's not really something that is explicitly mentioned. Okay, because this is more or less actually covered when you're doing practicals and stuff. Okay, so this is for 1.3. Okay, so let me scroll down to the last segment of 1.4. Okay, measurement of time. So this part here actually is to let you have an appreciation in terms of how people normally measure time, especially when there's no clock. So olden days, they use seasons. So if 4 seasons have ended, we know a year has passed. Sometimes we can also use moon. So we know that a month has passed when the moon shape changes back to the original. Sunsets, okay, obviously indicates a day. And last time people used sundial to so-called measure at what particular time, what hour it is in. Okay, but these are all olden days, right? Now we got clock. So yeah, clock is a lot easier to use. Okay, and it's a lot easier to find the precise and exact time. But without clock last time, these are the ways they used to measure time. Now, in terms of this particular portion about measuring time, okay, these are the few things. This pendulum thingy, okay, a pendulum is actually the main concept. Actually, it's the main thing here in the measurement of time. So, first things first, okay, why use a pendulum to measure time? Okay, because of consistency. Okay, it can measure even up to seconds. So you can actually use the pendulum to sort of like calibrate. Okay, calibrate means to adjust, such that you know that maybe 20 oscillation equals to how many seconds, and then from there you can calculate a more precise timing. Okay, this is the appreciation of this part here. However, if you just want to jump straight into it, why we talk about oscillation or what is an oscillation, what's a pendulum, and stuff like this, okay, we're just going to go into it. First things first, you cover here is, okay, definition over here. So each complete to and fro motion is one oscillation. So if you can see here, if let's say I start at R, the extreme left position, Going to S is not one oscillation. Only when it comes back, then is one complete oscillation. So you can see here an oscillation is a complete to and fro. Okay, to and fro. Just take note. Go there and come back. Go there and come back. So R, go over to S and come back. That is one complete oscillation. Okay, those of you who have done your practical in pendulum practical just recently only, okay, some of you forget what is a complete oscillation, so please wake up your idea. This part here, chapter 1, actually we covered before already. Okay, now, so once we know what's an oscillation, we can talk about period. So the period is actually the time taken for one complete oscillation. So if I were to start the stopwatch when the pendulum bob is at position R, when it goes to S, and then when it comes back, that is one complete oscillation. And you can find the time taken for this one oscillation, we call it the period. So this is another definition that you need to write down inside your summary sheet. Okay, now, so, okay, what kind of questions would normally come up for this? Why are they testing me? So obviously, practical is one thing that they will test you on this. Okay, but I think on the other part, I like you to highlight is this part here. Important concepts. Under your important concepts, you must write this down. The period of the pendulum depends on its length. Okay, so how long this string is? This is the length. Sorry. The length is this is right here. Sorry. Now for a pendulum bob. Okay, for a pendulum bob. Okay, I'm just going to draw it out here. Now, when we talk about the length of a pendulum, okay, it's actually from the top over here to the middle of the pendulum bob. Actually, to be exact, it is to the center of gravity. So this part here, from the point of, we call this the point of suspension. Okay, from the point of suspension all the way to the center of gravity, this whole part here, we call it the length of the pendulum. So for some of you, when you measure length of pendulum, some of you measure wrongly. I know some of you measure from this part all the way only up to here only. So this is wrong. This is not the length of the pendulum. It's actually from the point of suspension all the way down to the center of gravity. That's the length you should be measuring. Okay? So do take note. I like you put a star here. The period of the pendulum depends on its length. Okay, so if I can adjust the length of the pendulum, I can calibrate it. So calibrating it, to calibrate it, I actually adjust the length of the pendulum. Let me use back my favorite rate. So now, so the main point here is this. If I want to adjust the period of a pendulum, what can I do? So I want you to write this down under an important concept. To increase the period, so capital T is the period of the pendulum. So to increase the period, what can I do? I will increase the length of the pendulum. So L is the length of the pendulum. To decrease the period, I will decrease the length of the pendulum. So the length itself actually can cause the period to change. How does it change? To increase the period, I increase the length. To decrease the period, I decrease the length. So this is the main part here. I need you to remember with regard to the pendulum and how to adjust it. Has this come out in exam before? At least in our school paper, yes. For O-levels, I can't remember the exact one. Okay, I'll go back and find out. Okay, but you all can go and ask your teachers. Okay, has this come out before? So, but this definitely has come out for practical. Okay, so do take note of it. Now, one little thing I like to highlight in terms of important concepts is that this concept of human reaction time. Now, stopwatch, digital stopwatch can measure up to 0.01 seconds. You have gone to the lab, you have seen this. However, the problem is this. Human reaction time is about 0.3 to 0.5 seconds for most people. So if I were to press the stopwatch, it can't possibly be more accurate than, you see, if because of my human reaction time, you realize that I will be lagging or be a bit faster by 0.3 to 0.5 seconds. However, my stopwatch can measure up to 0.01. It's kind of funny, right? How can you, by pressing a stopwatch, give something that's more accurate, okay, up to 2 decimal place, whereas your problem is up to 1 decimal place in terms of seconds. So what is the implication of this? Okay, the implication of this is not so much for theory, but more for practical. So in practical, in your practical paper, do take note, stopwatch reading is recorded to the nearest 0.1 second. Okay, so instead of recording up to 0.01, which is the precision of the stopwatch, but due to the human reaction time, we actually will record it to the nearest 0.1 second. So this is more for practical time when you're using a stopwatch. You must make sure that you record it to the nearest 0.1 second. Okay, so let's go back all the way up here. Now, okay, you look at the learning objective. Describe how to measure a short period of time with appropriate accuracy using appropriate instruments. What is this instruments you're going to use? It's actually the concept of using a pendulum to measure time. Sorry, ugly handwriting. Let me change this a little bit to measure time. So pendulum can be used to measure time. How do you go about doing it? Okay, it's actually mainly to calibrate it. Okay, once you have calibrated it, you know that maybe 20 swings equals to 30 seconds. And then from there, you can actually use the pendulum itself to go and gauge how long other things are. Okay, so one way pendulum is actually used is the concept of your grandfather clock. So those of you who don't know what the grandfather clock is, please go and Google it. Okay? Now, so this part here, if you ask me, is actually the end of this whole pendulum part. Okay? Now, if you look at all this is actually things that you have covered in your practical. You have tried, some of you have tried it, some of you haven't, because you are absent or something. Or you do make sure that you have at least one try and try using the pendulum, because this has come up for practical in the last 10 years about twice already. Yeah, so important things to know. Okay, so yes, I think we are at the end of chapter 1. So for chapter 1, actually that's it. So just to do a quick recap of what we have covered, go all the way back to the front. What we have done is we have actually learned about what a physical quantity is. It consists of a numerical magnitude and a unit. We have taken note that the base quantities, there are total 7 of them, but there are only 5 main ones that we actually will be referring to it quite a fair bit. Next one, we have learned how to use prefix and symbols. We have learned how to remove the prefix. We have learned how to insert the prefix. And we have learned how to convert from one prefix to another. So that is for the first section, which is section 1.2. How about section 1.3? What did we cover? Section 1.3, first thing we covered was to sort of like to know which are the common sizes of object that we will need to possibly remember. First thing is size of an atom. Typically it's about 1 to the power minus 10 meters. We talk about size of Earth. We got to think about the radius and the diameter because they are slightly different. Radius is about 6 meters. Diameter is 10 to the power 7 meters. Okay. And also we talk about width of a human hair. It was about 10 to the power minus 4 meters. So this few, just be familiar with it because it has come out once in a while and I expect you to know it. Okay, next one, learn how to describe how to measure a variety of lengths using appropriate instruments. So tape measure, measuring meter rule. I think this one more or less you are quite familiar with it. For vernier caliper, we actually went through positive zero error. We went through negative zero error, and we learned how to read it. And we also learned how to correct it. Same thing for the micrometer. We also learn about the positive, negative zero error. We learn how to read the micrometer screw gauge, and we also learn how to correct the reading itself. So this is what we have done in terms of the measurement of length. And the last part, which is not covered here, actually we also talked a little bit about the idea of precision. which is the smallest unit that the instrument can measure. So that was for 1.3. Then of course the last thing we covered was actually 1.4. We talk about how we can measure time using a pendulum bob. So we actually talk about how to find time using pendulum. We talk about a few concepts such as your oscillation. We talk about period. Okay, and we did highlight that, if you were to increase the length of the pendulum bob, the period will increase. If you decrease the length, the period will decrease. So these are the key points in chapter 1. Do make sure you have all these details in your summary sheets. Okay, and I would like to end the Zoom revision lecture for chapter 1. Okay, so if you have nothing else, okay, I'm going to stop the recording now. Okay.